So today we're going to start our Folio task, and if you've checked your emails in the last half hour, you've seen I've sent you the assignment sheet. We're going to talk about the expectations around that. Just like I've said in the email, the draft will be Friday of week 3 of next term, and the final will be Friday of week 5. So we've got plenty of time to work on it, but I'm just giving it to you now so that if you want to get started in the holidays, you can. And then we're going to have a look at 4C, which is a short extension on what we're doing. Okay, so that leaves us with 4E and F to finish tomorrow before we go on holidays. The other thing you've seen, if you've checked the emails, is I sent you some holiday homework. Because we're having 2 weeks off, right? And so it's probably good to sort of keep the mind ticking over. I've just got a sheet that's summarising everything that we've done, and all of it is from our notes book. And you're just going to do a few questions, I would say, in the middle of the holidays, all right? Just so that sort of you're remembering it and you're not forgetting it before term comes back, okay? Just as a point of contact in the holidays. So I've emailed that through. I'll provide a hard copy tomorrow when I talk a bit more about it, okay? So today, Folio and 4C. Tomorrow, 4E and F, and we'll talk about the holiday homework. All right, so let's start talking about this roller coaster assignment. I've had a number of students over the years tell me this is the best maths assignment they've ever done. It's lots of fun. It even says it in the title, so you know it's going to be a fun assignment. All right. So just to begin with here, there's a little bit of a spiel about roller coasters. You know, they're an amusement ride. Who's been on a roller coaster before? Has anyone not been on a roller coaster before? Bailey, might be. Put that one on the bucket list.
We can do it as an excursion.
Excursion to learn about maths, eh? All right. So there's 2 parts to this task, okay? There's 2 parts to this task. The first part, part 1 here, is we've got a number of equations that we're going to solve, and these form a basic roller coaster track, okay? So in part 1, you're going to be solving the equations and graphing a roller coaster. Everyone's is going to be the same. All right? In part 2, you're going to create your own roller coaster using all of the types of functions that we've looked at. So today, I'm going to give an introduction on how we're going to solve part 1 and how you can start thinking about part 2. All right, so part 1 says solve the following equations, and it's going to be a fairly basic sort of roller coaster. Find the equation f of x, which is a line going through these points. This is representative of the initial incline so that it can get its gravitational potential energy. All right, so if it's all in the first sentence there. Find the equation of a line going through those points. So I'm going to do the first 3 with you. I'm filming it so you can refer to it later. You can write them down now if you want, but I'm going to just go through the first 3 and plot them so you get a bit of an idea of how to use the software that you're talking about. So part 1 says solve the equation of a line. It goes through the point 0, 0 and the point 23, 46. Okay, so if we want an equation of a line, right, an equation of a line has the form y equals mx plus c. We need to find the slope, right? The slope. And we've got 2 ways we can think about slope: change in y and change in x. Okay, if you can see it from there, that's good. Otherwise, using the slope formula, y2 take y1 and x2 take x1. So we haven't done this recently, right? This is from our last unit. And so you can see in this assignment, we're going to bring together all kinds of stuff from that we've looked at already. You've got it written in notes book, so and I'll help you out with developing it. So up here we've got 2 sets of coordinates. We're just going to assign x1, y1, x2, y2, and we'll sub that into the slope formula, right? So we'll have 46 take 0 on top of 23 take 0. 46 on 23, we have a slope of 2. All right. So the equation then is y equals 2x plus c, and c is the y-intercept, right? Remember, c is the y-intercept of the line. And so in order to find c, all right, you can probably see it from looking at the coordinates, but if you can't remember, what we do is we'd say, okay, well, it passes through either of these points. We can use this one. When x is 0, y is 0. All right, so I'm going to put the 0 where the y is, and the 0 where the x is. 0 plus c. What does c have to equal to maintain equality? 0. All right. Now that is confirmed as well because the y-intercept occurs when x is 0. So the y-intercept is going to be 0. All right, so this is the first equation. We've solved part A. The answer to part A is f of x equals 2x. All right, they've asked us to cool this line. They've said, cool it f of x. All right, so that's the first equation. All right, on to part B. Find the equation of a g of x of a quadratic. Okay, so now this is getting into what we're familiar with. It has a local max. It has a maximum point here, 2851, and it passes through this point, 2346. Okay, so when we think of a quadratic, a local max, it's going to look something like this, right? Local max at 2851. Okay, so we should be thinking then about how can I find a quadratic with that property? Well, remember y equals a times x take h squared plus k. That's completed square form where h and k are the coordinates of the vertex, the turning point. So we would have straight away from that, well, the equation of this quadratic takes this form, x take 28 squared plus 51. All right, and then we need to determine a, right? Well, we're given some other information. The equation of a quadratic has a local max here, and it passes through this point. X is 23, y is 46. When x is 23, y is 46. So we put that information, we're going to have 46. And then we're just going to process this for a. All right, I'll start by taking 51 from both sides. This will be minus 5. And minus 5 squared is 20, positive 25. Minus a fifth. All right, so we've got the second equation, the equation for part B. They've asked us to call it g of x. We found the a value is minus 1 on 5, and we've got the 28 squared and the 51. So that's going to be our answer to part B. We've found the equation of the quadratic. Okay, now with parts C and D, we're going to learn about those tomorrow. So I might just talk about C now because you might be able to answer it if you can remember some stuff from the previous unit actually. And I'll just rub out the first one there. Although I need something to it, there's some paper tape. Alright, so it says there's a cubic that has this form, x take h to the power of 3 plus k. Now, I'm just going to remind you of two things. I'm going to write it like this, a f of b of x take c plus d. Alright, this is from exercise 3F, and this describes how A, B, C, D affect a function. This is going to be fundamental to your assignment. A is the dilation factor, it stretches it and compresses it. You might remember the photo of the rock from the test. B is the horizontal dilation factor, stretches it and compresses it this way. But what I'm interested in here is C and D. All D does is move it up and down. Just grabs the whole function, moves it up, grabs the whole function and moves it down. And C moves it left and right. Alright? So we're told it has this form, alright, and we're told it has horizontal translation of 28. So that means it's moved across 28. All right, so I'll answer part C here. H of x is going to be x take 28 to the power of 3. Okay, so h is 28 because it's been shoved across 28. And the vertical translation of 51, so plus 51. Second? Excellent. Okay, so you can keep going and find the other equations there. So you'd be able to do all of them, except tomorrow you'll be able to do the quartic when we go over the lesson tomorrow. All right, so what I'd like to do then is, it's all well and good to find them, but what we want to do is we want to plot it. And so we're going to use some software called Desmos. I think I've logged onto it here with you guys before. So you just go to desmos.com and click on the graphing calculator, and it's just like what you have on your calculator, but it is sort of easier to maneuver and to fiddle things around with. So we have the first equation is f of x equals 2x. So I'm going to write that out. And then the second equation is g of x equals minus 1 on 5. X take 28 squared plus 51. And then the third equation, minus x take 28 plus 51. Okay, so I'll write there, h of x equals. All right, and you're going to have more functions, right? I've only done the first 3. You're going to have more. Your task now is to restrict their domain. We want to join them up together. At the moment, I can only see the first function, which tells me I need to zoom out a fair bit, don't I? So you can just take it and zoom out. We're only interested in positive values of x. Another thing you can do is in the settings here, you can set your v window. So I might just go from x is minus 1 to 50. And I might change y. We're assuming we're not going underground, I suppose, for now. So we'll go from y is 0 to, let's just say 70. All right, and you can see the 3 functions there, right? Now I need to figure out a way to restrict the domain of some of them. We've said this is our first function. It's got an initial incline, and then it's going to this blue function, which is this curve over, and then it goes to this wicked drop happening right there. All right, so we've got to restrict the domain. So I can use Desmos. I can go, all right, where do they meet? Okay, they meet at 46. So that means for my first function, I'm going to restrict the domain 23. The y value is 46. All right. So see what I did there? I've used these curly brackets, and I've said this first function, it exists between 0 and 26. And if I just zoom out a bit more, now you see the red line, it stops at 0 and it stops at 26. All right, 23. And then for the blue function's only existing over this interval. So I'm going to graph the blue function. All right, so I use my curly brackets. From 23 is less than x is less than, and I go, when does it meet the green function? And I can use either of these. I'll just use the first one, 28. All right, so I've got the red function, and it's joining up with this blue one, gives it a slight curve, and then we get that wicked decrease going down really fast. So I'll just say for now, where does it meet? 28. 28 less than x. All right. And then you're going to need to determine what's the next function. It's a quartic. It's going to look like this. All right, it's coming down and touching it. You need to figure out where does it meet and restrict its domain accordingly. So for the first part, what are you doing? You find all of the equations. All right, you plot all of them on the Cartesian plane, and you restrict their domain so that they form an approximate roller coaster track. Everyone's going to have the same answer for part 1. Okay. Any questions about part 1 so far? All right, so let's find the equations and then graph it over a respective domain. Okay, so that's something that you can do in the holidays. Start doing that kind of thing. So then in the next part, in the next part, what we do, I'm just going to delete all of this, we get you to create your own roller coaster. Okay? And so if you look at the assignment sheet, I'll just bring it up quickly. They give you some ideas. So that's part one. On to part two. Design your own roller coaster. And we've given you a few constraints here. A length of 400 meters, maximum height of 50 meters. And we want to use all of these kinds of functions. We're very familiar with lines and quadratics. We're going to learn more about these tomorrow. We've done circles before, and then I've got some ideas that you can experiment with as well. Okay, so let's just start with things that we're familiar with then. I'm going to go back and I'm going to say, we want a really steep incline initially. Most of you will have something like that. So let's just go to function 5x. That's going to be pretty steep, all right? Y equals 5x. And then I'm going to say, and I want it to have some sort of peak, a little bit like what we just saw before. So I want it to be some quadratic, and I want the maximum to be at 50 meters, right? The maximum height is going to be 50 meters. So when I'm thinking about a quadratic, right, if I wanted to have a max, all right, this is the general form of a quadratic in completed square. And you can add what they call sliders. So if I click, I've just typed them in here, you can drag the values of A and it changes its shape, okay? So H is shifting, you can see shifting it left and right, K moving it down and up. All right, and I can set it way bigger. I'm going to set K to 50 because I want it shoved up 50 units, right? H, how much should we have it moved across?
10.
Maybe a little bit more. Let's go 12, too much, 11. Okay, that's starting to look pretty good, 11.5. Okay, you can see you can just juggle them, 11.4, 11.3. That looks like a pretty nice touch there from the purple function to the black one. All right, so now that I've got those, all right, I've got A is -1, and even then you can change the value of A. Yes, it's -1. You can see how you can stretch it out. You can compress it in by increasing the value of A. All right, so you can fiddle with those and choose the shape that you want. Maybe you want it to have a more steady hill like that, in which case I should move it across a bit more. 12, 13, 14, 13.1. All right, so you can see there's a bit of fiddling around with it. Okay, so now I've got that equation, right? Over here I've got the value A -0.4, B, H 13.1, and K 50. So I can type them in. So we're going to -0.4 times x take h squared, 13.1 squared, and then plus 50. All right, now I can delete this function here, the general form of it. Delete all the sliders, just clears it up a bit. So I've got two functions so far. I've got a line and I've got a quadratic. Now what I'm going to do is restrict their domain. So they meet at 7.409. So we'll go, yep, x is less than 7.409, close that bracket, and then this one's going to exist for 7.409 less than x, all right, and then it's going to come down here and I'll go, all right, now I should add something else in. What should I put in there? How about a circle? All right, so the equation of a circle, right, is x take a squared plus y take b squared equals r squared. And we want a circle. I'm going to say I want the center of the circle about here somewhere. So what's that? 28 and 15. So I'm going to put those numbers in, 28 and 15. You can add the sliders and adjust it. And with a radius, like let's just put it in and experiment with it. Okay, how big should I make the radius? And then put it in so that it goes to there. What's that? Radius of 5.5. So I'll put that in. All right, we've got a nice circle there. It is a circle. The reason it looks like an ellipse is because of the because this is a rectangle, not a square, because it's in widescreen. All right, so then they meet at 22.5. So I'm going to restrict this one to 22.5. All right, goes into this one, goes around for a loop-de-loop, and then I'm going to say maybe that it meets another line up here. All right, so let's put another line there. Let's go for something like, no, that's too steep, half x. All right, and I can see I want this line to sort of just touch it. I want it to be tangent to it. So if you come down here and you go round, and then you sort of come back up this way a little bit. So I need to shift it down a bit, take 1, take 2, take 3, take 4. So you can add sliders or you can just deal with the numbers, right? Take 5, that's pretty good. All right, so then I'm going to restrict this one so that it exists for, and what do we want it to exist for? Let's say from there onwards, which is x is larger than 31.4. All right, and then I'm going to have it going into another loop-to-loop, but this one's just going to be super massive. So let's do a circle, and I'll stop after this one, guys. So let's go for 40 plus, and I'm putting these numbers in, but you don't have to get them perfect. Put them in and fiddle around with them, and then y take 30, and then equals 10 squared. All right, so that's pretty good, except it's not touching, is it? So that means I'll need to either move it across, in which case I can change this one, or move it down. All right, that's pretty good there. I'm happy with that. So, look, I've just created these functions out of nowhere. I've got a line, transitions into a quadratic, goes to a fully sick loop-to-loop, comes up, and then enters another even bigger loop-to-loop, and then maybe it'll come up, do another peak, you know, go into a little wave thing. There's lots of things that you can be creative with. Okay, so I'm showing you some fairly basic stuff, but yeah, once you start playing with it, you'll find lots of cool ways that you can manipulate these functions. All right.
Does it have to cover the full 400 meters of length, or is that the maximum?
That's the maximum. Yeah, 400 meters in length, the maximum distance. So 2 parts. The first part, all right, you've got the equations, solve them, graph them. The second part, creative. All right, get to be creative. So start with something like this, and once you get started, like you can use that to start with, that's fine, I'm happy. You can take these functions, it's film, use it, but everyone's is going to be different following that. Everyone's going to add their sort of different things in, different ways of doing it. Some people in the past have had them going underground, some people have had like wave functions happening. Yeah, there's been lots of cool stuff. All right, so in the holidays you can start working on that. All right, when we come back, we will have a lesson dedicated to how to write a maths folio. So that is how to bring this and the image you got in the first one, how to bring them together and write a maths report. All right, so I don't want you to worry about that part yet, but I do want you to maybe start doing some of the mathematics behind the report. All right, looks like fun. Excellent. All right, so I'll stop that one there. That's about our assignment, and then we'll pull out our notes books and let's have a look at 4C.